Hello everyone. Today we are going to discuss about the designing of deterministic finite automata which accepts the string starting with AB. Means whatever string we take, it should start with AB over an alphabet sigma equals to A comma B. So according to our question, we should design a DFA in such a way that it should accept a string starting with AB. Starting with AB means it should AB followed by any number of A's or B's. So like this the string should be. So the sample strings what we can write, the basic string is AB. AB followed by no symbols. So this is the basic string. Next stringing AB followed by only one A. AB followed by any number of A's. AB followed by any number of B's. AB followed by any number of A's or B's. Like this also it can be. So these are the sample strings we can consider for a given question. Okay. So we have to design a DFA which accepts the strings starting with AB. So it should start with only the string AB over an alphabet sigma equals to A comma B. And so if this is the question, then the string should start with AB followed by any number of A's or B's. So the basic string what we can get is AB. So AB followed by no A's or B's. Hence it is 0. Or at least one A. Or at least one B. Or any number of A's. Or any number of B's. Or any number of A's and B's. Or any number of AB, AB, AB like that. So these are the sample strings. So now by considering AB as the basic string, that is this one, AB as the basic string, we will try to design the finite automata. Okay. So now start from the initial state. Q0, AB, Q0 on reading input symbol A, going to the state Q1, then Q1 on reading the input symbol B, going to the state Q2. So this is the basic finite automata what we will get from the basic string AB because the starting symbol is AB, right? So that's why we have designed a finite automata like this. After AB, it can have any number of A's or B's. So after AB, we can have any number of A's and B's. Means we can put a self loop for Q2 followed by any number of A's or B's. Suppose if I take AB, A, B, A is accepted. Next is A, B, B. If I take one more string like A, B, B, this string should be accepted. So A, B, B. Hence it is accepted. Next is A, B, any number of A's. A, like that ending up to Q2 only. Hence it is accepted. A, B followed by any number of B's. So 1B, 2B, 3B like that any number of B's are accepted and ending to Q2 final state. Hence AB followed by any number of A's are accepted by our finite automata. AB followed by any number of B's are accepted by our finite automata. Next AB followed by 1A, 1B. This is also done. A, B, one time A, next time B like that. All these strings are accepted. According to the definition of a DFA, Q0 should have a transition symbol with A and also with B. But according to our question, it should start only with A, not with B. So if you are starting a transition from B from state Q0, then it should go to dead state. Take that state as Q3. So if I start with B, then it should not reach to final state. Hence we will call the state Q3 as the dead state. Okay. So now Q0 is having transition with A and B. Q1 is having transition with B. The second symbol should be B. It shouldn't be any other symbol. So it shouldn't be A. So from Q0 on input symbol A, it is moving to Q3. Okay. So Q3, why we are passing this to Q3? Because if we are starting with B means it shouldn't reach to final state. If the second symbol is A, then it shouldn't reach to final state. So there shouldn't be path from this state to final state. Even though we are starting from Q naught initial state, but this state shouldn't reach the final state. So that is called as the dead state. So now Q naught is having transition with E and B. Q1 is having transition with E and B. Q2 is also having transition with E and B. So Q3 is also a state in this finite automata. Hence, it should also have a transition with E and B, and it shouldn't reach to any other state. If it is reaching to Q0, it will move to final. If I make a transition to Q1, it will move to final state. Hence, we should make a self loop with the transitions E and B. Hence, it is not reaching to the final state. So, hence, this is the finite automata which accepts the string starting with AB symbol. We will consider two examples. One is a string which is accepting the which is accepted by this finite automata. That is AB followed by any number of A's and B's, means I will take ABA. This is one string, means AB followed by any number of A's. Starting symbol should be AB. This is one string which should be accepted, and we will take another string like BA. This string is not starting with AB, hence this should be rejected. So we will consider these two examples and try to make a transitions over this input symbols. So we will make delta star of, always we should start with initial state and end up with the final state. Then we can tell that the string is accepted. So we will start from Q0 over a set of strings A, B, A, B, A. Okay. So now Q0 on A, Q0 on A is Q1. So we will write Q1. So this symbol has been read. What is the left out strings that we have? That is BA, BA. Okay. Next step. Q1 on B. So Q1 on B is Q2. So Q1 on B is Q2. So it's done. Left out strings are A, B, A. Right? Next, Q2 on A. Q2 on A is Q2 only. So we will come to state Q2. A has been read. Now the left out strings are BA. Now Q2 on B. Q2 on B is Q2 only. So now Q2 on B is Q2 A. Q2 on B is Q2. Remaining is A. Next Q2 on A is Q2. Q2 on A is Q2 only. So now we will get Q2. Hence, we are ending up with the state which is final state. So Q2 is the final state. If you start from the initial state and ending up to the final state, then we can tell that the string is accepted. Okay. Now we will check for BA, BA. Delta star of, start from the initial state Q0 with BA, BA. That gives Q0 on B. Q0 on B. Q0 on B is, it is going to dead state. Means Q3. Q3 with B is read. Left out strings are ABA. So we will write ABA. Next, Q3 on A. Q3 on A is Q3 only. So Q3, left out strings are B. Next Q3. Q3 on B is Q3 only. So left out string is A. Q3 on A is Q3. See, Q3 on A or B or A or B, it will end up to the same state. Hence we are reaching to Q3, which is non-final state. So if you are starting from the initial state and you are reaching to a non-final state, hence we can tell that the string is rejected. We will call this as accepted and this as rejected. For a DFA also you can check AB, ABA. A, B, A, B, A. So ending with Q2 only. So it is accepted. Now if you check BA, BA, B, A, B, A, ending up with the non-final state. Hence it is rejected. Okay. So in this way we will able to design a finite automata for a string starting with A, B. Hope you have understood this particular problem of designing a deterministic finite automata, that is DFA. In the next session, we will try to design more DFAs and understand very detailedly how we can able to design a deterministic finite automata for different types of regular languages. Okay, until then, see you. Bye.